So the final part of the configuration is something specific to vPC again, so it's related to what we call Infra VLANs, which are required for backup routing. So for example, if Leaf 1 managed to lose both of its uplinks to the spines, but it still kept its vPC peer link and its peer adjacency with Leaf 2 up, and these two servers were still connected to Leaf 1, what's probably going to happen at some point is the hashing algorithm that's being used on these servers is going to send some traffic up to Leaf 1, and if it's unable to contact both spines, it's not going to be able to do anything with that traffic, and it's going to black hole it. So what we'll do to simulate this is on Leaf 1, we'll shut down its interfaces to the spines, and then on the spines it's ETH1/1. We'll just shut it down on both sides, because sometimes the NX OSV can be a bit weird with one side being shut down, one not. So I'll shut it down on both sides. And what we should see once we've done that is on Leaf 1, if we do a show IP route OSPF underlay, that we haven't got any routes in there anymore. And if we do a show IP OSPF underlay neighbours, we haven't got any neighbours anymore. And if we do a show BGP LTVPN EVPN summary, they will be on the way down, because obviously there's no routes for them, so that'll take however long BGP wants to work out what the hold time is, but they eventually will go down and will lose all of the routes essentially, because the interfaces towards the spine is no longer serviceable for whatever reason, whether it's a line card failure or someone accidentally moving some cables around. It can happen, and that's the reason why we have the Infra VLANs stuff. So wait for these to go down, but either way, the configuration that we need to do is it's similar to what we did with the backup routing between Leaf 3 and Leaf 4 when we did the tenant VRF in the last video with the external routing. We essentially need to create a VLAN, we need to give it an SVI, but instead of adding it into a tenant VRF, we leave it in the default VRF, and it becomes an extension of the underlay, so that we have an OSPF adjacency between our two VPC peers. And essentially that then allows Leaf 1 to use Leaf 2 as a backup path to get back into the fabric. So what we'll do is we'll do this just on Leaf 1 and Leaf 2 just to prove the point, and then in effect the config is the exact same on 3 and 4 and 5 and 6. We just need to pick different IP addresses basically for the SVIs, but we'll create a VLAN 900. We will then create an interface for VLAN 900, an SVI. We'll no shut it. We'll say no IP redirects, IP address. We'll say 10 dot, we'll say 0.3.1/30 IP OSPF network point to point IP router OSPF underlay, put that in the backbone area. And then what we have to say specifically to enable this to be an infrastructure VLAN, which is essentially a way for us to tell the NVE interface that this is not an L2 VNI. It's a VLAN that's required for infrastructure essentially. So we say system NVE infra VLANs 900, and if we do a show NVE show system NVE infra VLANs, we should see that we have a current active infra VLAN. There are certain requirements with the VLAN that you've got to make sure you conform to. So just make sure you're picking a VLAN that it's going to allow you to use. So what we'll do is on leaf 2 we'll do the same thing. So VLAN 900 int VLAN 900. We'll no shut it. Say IP address is 10.0. What did we say? Grab that. And this will be .2. We'll say no IP redirects IP router OSPF underlay area 0, and then we'll also say IP OSPF network point to point. And last but not least, system NVE Infra VLANs 900. And hopefully what we should see on here, on leaf 1 should I say, is show IP OSPF neighbours. We should see that we do now have a neighbour and it's been formed over VLAN 900. If we do a show IP route, we should see that we've now got all of our routes back for the underlay via VLAN 900. We should be able to ping, for example, 10.0.0.1, which is a spine, and 2, which is the other spine. And if we look at show BGP L2 VPN EVPN summary on that, even though we didn't see them go down before, we can see that these have been down because they've got an uptime of 39 and 35 seconds. So now the connected devices on leaf 1, so you could have an orphan port on that's directly connected to leaf 1, or something that's got a VPC and it's hashing the traffic up to leaf 1. It's now going to have connectivity using VLAN 900 back to the fabric. So if we then just simulate these links coming back up, and just give this a bit of time to converge, we'll start to see that things start to move over to ETH1/1. There is always going to be some that are going to prefer to use VLAN 900, mainly prefixes that live on the other VPC peer. So for example, that is the loopback of the other peer, and there's other, that is the other loopback of the peer. So this is loopback 0, this is loopback 1, and then down here we've got the other subnets that essentially we're using for the VLAN 900 peering. But there is always going to be some traffic that will use the Infra VLAN. So it's not only going to be used in the event of an outage. It will be used for some normal traffic. So the last thing we need to do to complete the configuration, much like we did with the peering, the BGP peering that we did between leaf 3 and 4, the border leaves, we need to enable layer 3 peer router underneath the VPC domain for both leaf 1 and leaf 2. So we'll come into VPC domain 100 and we'll say layer 3 peer router, and we'll do the same on leaf 2. Domain 100, layer 3 peer router. That configuration is the same on all the other leaves. You just need to change the IP addressing on whichever SVI you use when you configure it. So, thank you.